Hey guys, I wanted to give us some common background because we're not all in the same place as far as understanding what's going on in this section. I'm going to do a couple problems from each piece and try to go through things again in a more didactical fashion of me explaining what's going on rather than you figuring it out. So that if you've come this far on your own, that's awesome, and you can use this to kind of cement some of these things in your mind. And if you need a little bit of help to make the next steps on your own, that's okay too. And you can use this to help get to where you need to be. Okay, so we're going to use the given point on the terminal side. Okay, that just means wherever this thing ends up to find the value of the trigonometric function indicated. I'm going to zoom in a little bit so we can see this a little bit better. And what we talked about with regards to this in class was we're adapting to a new world where we're going to draw reference angles, and we're going to look at our x and our y values here. Our x value would be negative 14, and our y value would be 17. The next thing we have to do is to be okay with the idea that we have a negative length here. The negative length doesn't actually mean that it's a negative length like it went backwards in time or something. It just means that it's going to the left 14 instead of to the right 14. The tangent value of this angle would end up being, so based on my angle here, my opposite divided by my adjacent side, or 17 over 14. I'm sorry, 17 over negative 14. I'm going to look at number 3. I was supposed to say number 9 because there's 9 in this problem. Where we're going to do the same thing. Here we've got to make our triangle. We're going to make it with the x-axis. Really focusing on this reference angle where we have a height of negative 12 and a base of negative 9. I can use the Pythagorean Theorem, even though these are negative values. So that's negative 9 squared plus negative 12 squared. And that's equal to c squared of my hypotenuse. So 81 plus 144 is going to be 225, which is c squared, and that gives me a hypotenuse of positive 15. The hypotenuse will always be a positive value because that really is a length. The other two tell you change in position. That one is an actual length, so that one will remain positive. Okay? Cosine of this angle, which is this angle marked in red, but we're also going to relate that to this reference angle, is going to be equal to the adjacent to this reference angle divided by the hypotenuse, or negative 9 over 15, which could reduce into negative 3 over 5. Our next page, we were asked to take a look at something called the unit circle. The big thing in the unit circle is that the radius here is equal to 1, so that if I were to take a look at any radius in the circle, for example, including this radius, it has a length of 1. Going with this, we're going to make a right triangle, and altitudes are going to be drawn to the x-axis. The measure of the hypotenuse in each triangle is going to be 1, and that's because they are radii. And in my circle, the radius is equal to 1. Find the exact length of each side using knowledge of special right triangles. Hint, your answers will have some radicals in them. And one of the things that we saw above is that this was a 30-degree angle, which means that this is going to be a 30-degree angle as well. In a 30-60 right triangle, we have the relationship. You guys tend to like looking at this as 2, 1, and square root of 3. We're going to divide each of those by 2, so it looks more like the one we have here. So we get 1, we get 1/2, and we get the square root of 3 over 2. And in fact, those are going to be my lengths here. So this bottom length would be the square root of 3 over 2. and this vertical length would be 1/2. My coordinates here would be the square root of 3 over 2, comma, 1/2, which we're going to need for part 10 anyway. The other one is going to be another square root of 3 over 2 on the x part. And this one is going to be negative, and we're going to have a negative 1/2 on the y. The coordinates for this intersection point are going to be negative square root of 3 over 2, comma, negative 1/2. That takes care of 9 and 10. For number 11, we've got to find sine of 30 degrees. Well, based on this triangle, so sine of 30 is going to be opposite divided by hypotenuse. Sine of 30 is going to be 1/2 divided by 1, which is 1/2. It looks to me that that's the same as the y coordinate. For cosine of 30 is equal to, and that's going to be adjacent divided by hypotenuse, root 3 over 2 over 1, which is just the root 3 over 2, and that's going to be the same as the same as the x coordinate. That's kind of interesting for us to notice. Finally, tangent of 30 degrees is going to be the opposite divided by the adjacent, or 1/2 divided by the square root of 3 over 2, which I could rewrite as a division problem. 1/2 divided by the square root of 3 over 2, which is the same thing as 1/2 times the reciprocal, or 2 over the square root of 3. My 2 is reduced to 1, and I get 1 over the square root of 3 is my answer. That one's a little bit harder for us to notice any comparison, but you might notice this is the y coordinate divided by the x coordinate at the beginning before you start simplifying. For number 12, we're going to begin to digest some words. Here it says the sine of an angle can be defined as the ratio of, so we have the y coordinate, to the length of the radius of the intersection of the terminal side of a central angle with a circle of given radius. Wow, that's a lot of stuff. So it's the y coordinate. So if I have an angle, the intersection of the terminal side of a central angle with a circle of a given radius, that's going to be my intersection, okay? So we're talking about the y coordinate here, and with the radius here. So sine of an angle could be described as y divided by the radius. Cool. Cosine of an angle, similarly, can be defined as x divided by the radius, where x is the x coordinate of that intersection. Tangent can be defined as the y coordinate to the x coordinate ratio. So tangent of an angle would be the y divided by the x. And again, given any angle, these are the coordinates we're talking about. If you know these coordinates and you know the radius, you can calculate the trig values without actually having to go into the problem and do some triangle work. For cosecant, well, if sine is y over r, cosecant is r over y. For secant, if cosine is x over r, secant is r over x. And cotangent, if tangent is y over x, cotangent is x over y. Where are things positive? Well, if I think about this way, we know that our x, y coordinates are going to be positive in quadrant 1. In quadrant 2, they're going to be negative and positive for x and y. In quadrant 3, they're going to be negative and negative. And in quadrant 4, they're going to be positive and negative. the way this should be a negative over here, the parentheses kind of crossed that and made it look like it was positive. Okay, if I think about the idea that our radii are always positive, so we're looking at sine of an angle is positive when y divided by the radius is positive. That means when y divided by a positive number is positive. That's only going to happen if we have a positive divided by a positive. So sine is positive, in other words greater than 0, when y is greater than 0. That happens in quadrants 1 and 2. Cosine of an angle is positive. In other words, when x divided by a positive number is positive. This is only true when x has positive values. That happens in quadrants 1 and 4. Tangent, I'm going to drift down the next one for this, of an angle is greater than 0 when y divided by x is positive. That only happens if x and y are both positive or x and y are both negative. The only way to get a positive number when dividing is if either both are positive or both are negative. Well, in quadrant 1, they're both positive. And in quadrant 3, they're both negative. The cosecant, secant, and cotangent go with their reciprocals. We don't need to talk about those separately. And finally on this page, does it matter what we use as the radius? And the answer is no. The first way we developed right triangle trig was looking at similar triangles. And in this, we're kind of taking that to the next level. The radius doesn't matter because all of these are ratios. And if you were to choose a radius, I don't know, like pi, or 17, or 37 1/3, all of those would end up giving you the same trig ratios. My idea here is why don't we use the easiest number possible so that when we're dividing by that number, we don't end up getting really lost in what we're doing. And that easy number to divide by is going to be if we make the radius equal to 1. For number 13, we got to graph the first quadrant, and we've identified 0, 30, 45, 60, and 90. I'm going to just mark these. That's 0 degrees, that's 0 radians. That's going to be 30 degrees, otherwise known as pi over 6 radians. That's going to be 45 degrees, otherwise known as pi over 4 radians. We're going to have 60 degrees, which is the same as pi over 3 radians. And then 90 degrees, or pi over 2 radians. Part 2 is we need to identify the coordinates for each of these. The coordinates of the first intersection are going to be 1, 0. For the 90, similarly, that's going to be 0, 1. We did the coordinates for the 30-degree one a couple pages back, and that was the square root of 3 over 2, 1/2. The 60-degree one, if you were to make that triangle, you'd end up getting the same exact thing, but with a 30-degree angle up top. This is going to have the coordinates of 1/2, the square root of 3 over 2. And finally, we need to figure out the coordinates for this 45-degree angle. I'm going to pull this one out, where we have a 45, 45, 90 right triangle. And again, generally, we talk about this with regards to a hypotenuse or radius of 1, although you guys are a lot more comfortable with something that looks like n times the square root of 2. One way of thinking about this is to do the Pythagorean Theorem, n squared plus n squared is equal to 1 squared, and solve it from there. Another way, if you remember that the setup of the n root 2 thing, you can say, okay, well, if n times the square root of 2 is equal to 1, that means that n has to equal 1 over the square root of 2. For the sake of common notation, we usually rationalize this denominator, and this is the same thing as saying the square root of 2 over 2. So you will usually see this point written as the square root of 2 over 2, the square root of 2 over 2. For the bottom part of this page, we're going to use our knowledge of trig and our knowledge of what we just did with unit circle trig to get these values for 14 through 23. For example, we know that sine of theta is going to be the y-coordinate divided by the radius. The radius here is always going to be 1, so the sine is just the y value. For 45 degrees, we've got the coordinate root 2 over 2, comma, root 2 over 2. The y-coordinate is the square root of 2 over 2, so sine of 45 is the square root of 2 over 2. Cosine of an angle we defined as x divided by the radius. In this case, the radius is equal to 1. So we can just say the cosine of something is equal to x. Cosine of pi over 3, I'm going to look at my pi over 3 coordinates, that's up here. So that's a half, comma, root 3 over 2. And I'm going to look at the x coordinate. In this case, that's a half. Cosine of pi over 3 is equal to a half, and I wrote a third. Nice. Tangent of an angle is equal to the y-coordinate divided by the x-coordinate. In doing that here, so at 0 we have 1 comma 0 as my coordinates. The y divided by the x is 0 divided by 1, which is just 0. Going a little bit faster through some more of these, sine of pi over 3 means the y value at pi over 3, or the square root of 3 over 2. Cosine of pi over 2, looking at the points at pi over 2, the x value is going to be 0. Cosine of pi over 6, looking at my pi over 6 points, and the x value for cosine is going to be the square root of 3 over 2. Cosecant is going to be the reciprocal of sine. So if I can find sine of 60, and sine of 60 is the square root of 3 over 2, then the reciprocal of that would be 2 over the square root of 3, which is okay to leave. Tangent of pi over 4, okay, pi over 4 is right there. That's going to be root 2 over 2 divided by root 2 over 2, because tangent is y divided by x. And if I'm dividing these two things, the answer is 1. Cosecant of pi over 3, well, pi over 3 is up here. Cosecant is the reciprocal of sine, and, oh, we just kind of did that one. 2 over the square root of 3. Tangent of 45, y divided by x there is going to be 1 again. For these problems, we're working backwards. Instead of trying to find the coordinates, we're given coordinates and we're trying to find angles. If sine of theta is equal to 0, that means that y is equal to 0. The only angle that would make this true would be at 0 degrees or 0 radians. If cosine of an angle is equal to root 3 over 2, that means the x is the square root of 3 over 2. The only place in here that I have an x value of the square root of 3 over 2 is going to be at pi over 6. Looking at, I don't know, let's say cosine is a half. I'm looking for where x is a half going up my unit circle. That's going to be up here. That means that my angle has to be pi over 3 radians. For something like 31 where I'm given a root 3 over 3, that's not one of these values. It's also tangent, which means I have to deal with this with division. The only coordinates that could feasibly give me a square root of 3 are up here, where I'd have the square root of 3 over 2, divide by a half, or down here where I'd have a half divide by the square root of 3 over 2. I've got to do x over y in both of those cases. Square root of 3 over 2 divided by a half is going to be just the square root of 3. Nope, it didn't work. A half divided by the square root of 3 over 2 is going to be 1 over the square root of 3, which doesn't look like square root of 3 over 3. But we talked about rationalizing denominators. If you were to rationalize this, you get 1 times root 3, which is root 3. Root 3 times root 3 is going to be the square root of 9, which is 3. What this means is that that was true. This was our lower angle, or pi over 6. When we get onto to number 36, we're beginning to look at this as a whole universe and not just the first quadrant. I'm going to add in the coordinates we already know. That's 1, 0. That's going to be the square root of 3 over 2, 1/2. That's going to be the square root of 2 over 2, the square root of 2 over 2. Also acceptable there would have been 1 over the square root of 2, 1 over the square root of 2. Here we've got 1/2, the square root of 3 over 2. And up top we've got 0, 1. I'd like you to think about this in terms of what you did in geometry for reflections, but also just kind of thinking logically. Let's do the easy ones first. Back here, we're 1 unit back and we're 0 units up. We've got the coordinate -1, 0. Down below, we've got 0, -1. Looking in the second quadrant, the first point I might look at is this guy, which came from a 60-degree reference angle. And in looking at this, this looks like it's reflected of the pi over 3 point over the y-axis. In fact, it is. And we already talked about in the second quadrant, we've got a negative x and positive y. We could use the same exact coordinates that we had, but with a negative x and a positive y. The same is true for my next value, which reflects my 45 or pi over 4. And looking at that, we had root 2 over 2, root 2 over 2. Here we'd have the same thing, but with a negative x, so negative root 2 over 2, positive root 2 over 2. Moving onward, we have our pi over 6 mirror. This is going to be a negative root 3 over 2, positive 1/2. Into the third quadrant. Try these if you're trying to follow along in the video before looking at the answers to these. We know we're looking at negative values for both. This is my reflection of the negative 30-degree angle. So we're at negative root 3 over 2, negative 1/2. This is my reflection of my pi over 4 angle, which is negative root 2 over 2, negative root 2 over 2. This is my reflection of my pi over 3 angle, negative 1/2, negative root 3 over 2. And finally, in the fourth quadrant, we know we've got a positive x and a negative y. Okay, this is my reflection of my 30-degree angle. So that's positive x, root 3 over 2. And reflected down, the y-coordinate would be negative 1/2. We're going to have the square root of 2, that's a 2, over 2. And then a negative square root of 2 over 2. And finally, we're going to have positive 1/2 for the x and negative the square root of 3 over 2 for the y. Finding each of these trig functions is going to be a little bit more complex, but not a heck of a lot. The first thing I've got to do is to figure out where an angle is. So 210 degrees, that's going to be 180. 210 is going to be 30 degrees past 180. We're really looking at, if you want to think about this in terms of triangles, this guy down here, that's my reference angle. It's a 30-degree reference angle, but I can even just look at these coordinates. Cosine is going to be the x-coordinate, which is the negative square root of 3 over 2. 38, cosine of 150. I'll do this one in a different color. Let's look at this in terms of orange. So 150 is going to be 30 degrees less than 180. So we're looking at a 150-degree angle with a 30-degree reference angle. I'm going to use the x value, which ends up the same as what we just had. So negative the square root of 3 over 2. Cosine is 7 pi over 4. I'm going to change colors again. 7 pi over 4, well, I know that's bigger than pi, because 4 pi over 4 would be 1 pi. It's smaller than 2 pi, but it's not quite that much smaller. So 7 pi over 4 you might think about as 1 plus 3/4 pi, because that's 4 over 4 plus 3/4 pi. So we're going to go 1/2 circle, that's pi, and then 3/4 of a half circle to get me to 7 pi over 4. If you converted this to degrees, you'd find out this is 315 degrees, and that's okay to do for now. You will at some point need to get used to using radians, but now it's okay if you do the conversions. 7 pi over 4, cosine again is going to be the x value, and down here the x value is going to be the square root of 2 over 2. Tangent of 5 pi over 4 is the last one I'm going to do. I'm going to switch colors once again, and in doing that, 5 pi over 4 is going to be down here. Tangent is the y divided by the x. So we get negative the square root of 2 over 2 divided by negative the square root of 2 over 2, which happens to be 1 is your answer.